This is the 14th part of the our following series, data structures and algorithm. And today we are going to start a new type of data structure, which is stacks. So this is very helpful data structure when it comes to programming and computer related stuff. So this is basically related to array implementations. So we have successfully discussed all of the basic operations that can be performed on the arrays. So in here in stacks, there are also major operations uh, that can be performed on, and you will be seeing what are those in our upcoming slides. This upcoming slide series. Uh, Okay, so you might have heard of this data structure, which is stack. This is also a static linear data structure. It means linear means basically it stores all the data elements on your physical memory at the continuous locations. So you probably might not be having any kind of idea what are the continuous locations and how those elements has been stored on your memory, type of things. So don't worry, I will be explain those things in later episodes, uh, because those are not necessary to knowing in this state. So just remember, stack is static linear data structure. So you know what are the static mean. Static mean you can't change the stack size in the runtime of the program. So array is also static data type, and stack is also static data type, which means you can't change the size of the stack in the runtime process. So if you want to change the size of the stack, you should do it before the compilation process. Like defining new type of value for the max size of the stack. So you will be see these things in upcoming a few moments later. So let's move to the next slide. Okay, what is a stack? Stack is a linear data structure, which I said before, and that can perform insertion and deletion only at the one end, and that end is called as top. So this is very essential thing when it comes to stack, and this is the major thing you should know about stack, which is there is a pointer, which means a specific location called top on the stack, and you can only perform delete and insertion operations at that end. So if you remember what we have done in the previous episodes, in the array implementations we have done so many operations, like deletion, insertion, searching procedures, sorting procedures. So we never use a pointer before, which means we haven't implemented those procedures in a specific location. So imagine if you, so I'm talking about arrays now. Okay, I'm not talking about stacks now, for just for giving an example for you guys. So in the arrays, if we want to perform the deletion operation, we just call where we want to delete. If you want to delete the element at the second index, so that's okay, we can perform that operation at that index. If you want to delete the fifth element, we can do that. So if you want to do sorting procedures, we can also do that. We can do, if you want to do searching procedures, Yes, we can do that also. So but when it comes to stack, those kind of things are a type of difference. Basically we are not going to talk about searching procedures and sorting procedures according to stacks. So make sure you thorough with these things. Only thing you should have to know upon your mind is there is a pointer called top, and all of these operations that you are going to do on these stacks can be performed only at that point, only at that topmost location, or only at that specific point. Okay, so basically stack is a representation of real world physical component like stack of plates, stack of coins, and stack of chairs. So those are stacks, kind of a group. So when it comes to stack of plates, you can take plates at the topmost location. Oh, let's say you generally take plates at the top. You can when it comes to a physical, when it comes to a real world situations, you can take plates at the middle or at any kind of place, but normally we are taking the plates at the top. So like a stack of coins, we are put coins, or we take coins at the topmost location. So if we try to insert or get a coin at the middle position of this stack of coin, then this stack will be collapsed, or something like that. Okay, so this one is very general to stack, which is the stack of chairs. So stack of chairs, remember, uh, uh, a stack of chairs. So you can only take and only you can take and put chairs only at the top location. There is no way to get chairs at the middle of the position. Well, you can get the whole module at the middle, but you can't get a single chair at the middle of the position uh, in this type of stack of chairs. So this is very general too that we are going to talk about in this uh, data structure, which is this stack. So yeah, those are the general things about stack. Stack of plates, stack of coins, and stack of chairs. Okay, uses of stack. When it comes to computing, stack is one of the most useful data structure. So I said this thing before. So I have given 4 things that we can perform by using stacks. The first thing is compilers use stack to evaluate mathematical expressions. The example is to check the validity of the mathematical formula. So yeah, you if you are a programmer, if you have done code before, you might have some kind of idea what are these compilers are. So basically compiler is a kind of a translator that generate a specific machine language code to your high level language code. So basically imagine it's some kind of a translator. So there are several types of compilers out there. So basically those kind of compilers use stack for check the validity of the given expression that we have been given to the program. So okay, let's take a simple example like when you are doing your C code, you done some mistake. So if you done some mistake, okay, you can type codes, but when you are compiling, when you are press compile button, it won't be compiled. It will give some error. There will be some kind of error. There will, oh, let's say there is a syntax error at this line and this column. So you should fix it before compile. So that's the thing. Compilers basically use stack uh, for check the validity of your expression. So basically it is very valuable because if you are because your program must be contain some kind of errors, so it won't be efficient if it continue with those errors. So before continuing those kind of syntax errors, the compilers can check if there are any errors or not. So it uses this step. Okay, and the second thing is stack can use to reverse things. Okay, so basically reversing means imagine you have some kind of a linear data structure which having the continuous data in some kind of order. Let's say you having the numbers like 2, 5, 3, 8. So reversing means it printing the backward like 8. Okay, I don't remember those numbers now. Okay, you get the idea. So 2, 5, 3, 2, like that. You printing or outputting, printing or do outputting backward. That is the reversing. And the third thing is stack can use to matching up related pairs of things. Okay, that is basically like the first one. Like it check the validity, and in the third one it says matching up related pairs. So imagine your expression is having brackets. Okay, so those brackets should be in some kind of order. Otherwise it is not generalized, it is not correct. So yeah, you will be seeing those things in later. So just for now, remember stacks can be used to check the matching pairs. And the first thing is stack based programming problems. Okay, so in here I have listed 4 things, and we will be discuss each of these things in very descriptive descriptively in later episodes. So for now, just remember we can use this tag for reverse string or number, and the second thing is to check if a word is a palindrome or not. The third thing is to check a validity of the brackets, and the fourth thing is convert infix and infix expressions to postfix. So you might not be having any kind of idea right now what are those, and what are the palindromes, what are the validity of the bracket in presence, infix expressions and postfix expressions. So it doesn't matter, this is just an introduction. So later in later episodes you will be learning these things very descriptively, so don't worry right now. For now, just remember we can do such things by using stacks. Okay, let's move to the next slide. I missed the one slide. Okay, stack operations. So there are 3 operations that we can perform on these stacks, and I can consider these things as you can consider these things as the major operations that we can do perform on the stacks. The first thing is push operation. The second thing is pop operation, and third thing is peek operation. And in later I will show you what are those in the descriptively. For now, just remember those are the major operations. I said the major operations. Okay, so I never said those are the only operations. There are some kind of operations that we are going to learn in later, but these 3 are the major, which is the pop, push and peek. So basically what is the push operation? So push means inserting element to the topmost location at the stack. So I said before, in the stack we have a specific location called topmost location, and that is our pointer. So we can only perform our actions on that location only, which is the topmost location. So if we want to insert some kind of element to our stack, then we can perform that operation at our topmost location. And if we insert a value at the topmost location, it is known as push operation. Likewise, the pop operation means if we want to delete an element from the stack, we can do it, but we can only do it at the topmost location. So if we delete some kind of a element at the topmost location, and that procedure called pop operation. It's very simple. Remember, push is inserting, then pop is deleting. But in this text, we can only perform inserting and deleting at only the topmost location. Third thing is peak operation. So basically, peak operation means the see the topmost element. So it is not deleting. Okay. So if you are delete, which means if you pop an element from the stack, that element will be deleted. It could be printed, but that element will be deleted. But in the peak operation, this won't happen. It is not deleted, but it could be printed. Like basically, imagine you want to know what is the topmost element that we have in our stack. So you can perform simply peak operation. If you perform peak operation, then it will give the output. This is our topmost location, and remember, it won't be deleted. It's just simply printing. So basically, for now, remember, push operation is same as insert, but only can perform on the topmost location, and pop operation is simply like deletion operation, and it also only can perform on the topmost location. Peak is basically printing the element, but it also only can be performed at the topmost location. Okay, so those are the three major operations that we can perform on the stack. Okay, stack implementation. There are two types of implementation, which are the first one is the array based implementation, which is the static implementation, and the second one is linked list based implementation, which is the dynamic implementation. So if you follow my previous episode before, then we had talked all the operations by considering the arrays. So you have learned array is a static data type, which means we can't change the maximum size of this array at the execution period or the runtime period. So that is why we calling in this static data structure. So in this stack, we can make our stack by using arrays. So if we make our stack by using arrays, then our stack will be static. So we can also make our stack by using linked list. So if you only follow this tutorial series right now, you don't know what are the linked list mean. So because I haven't discussed it, so it is basically also a data structure, but it is dynamic. So I will be teaching this linked list in the later episode, you guys, because it's kind of difficult to understand at this moment. So it is not basically simply like arrays. There are several things that you should know about linked list before it should be implemented. So for now, just remember, we can implement stack by using both arrays and linked list. But for now, we have only learned arrays. So we are going to implement our stack by using only arrays. Okay, let's move on next slide. Okay, this is the explanation that I explained before. So array based implementation is array is a linear data structure. Therefore, stack that creates using is array automatically become static, and array based implementation for stack is very easy because array implementation is very easy. So stack implementations by using those arrays are very easy. And the major disadvantage of array based implementation for stack is it is necessary to define max size of the array at the beginning, and this max size can't change at the compiling time or the execution time or the runtime. And I said this before, I said this thing before also, because array is a static data structure, therefore we can't change the max size at the execution period, so that is a disadvantage. Okay, linked list based implementation. So basically linked list is a dynamic data structure, therefore stacks based linked lists are very flexible and effective, but this cost some kind of a let's say it is kind of difficult. It is not like simply as arrays. There are so many things going on linked list in order to make that thing as flexible and effective. So if you use linked list for our stacks, then it is automatically become flexible and effective, which is good, which is very good uh, at that stage. And defining the max size at the beginning is not necessary, which is advantage because linked list have no limitation, because as I said before, linked list is a dynamic data structure, therefore it is no limit. It is in there you can define an infinite number on that linked list, so there are which means there is no limit. Therefore stack based linked list have no limitations. Okay, so those are the two major types of implementation that we can consider when it comes to stacks. Okay, how stacks work? Pop operation and push operation are the most significant thing that can be performed on this stack. This is how it works. Okay, this is bit of an error. I think I did some wrong at the animations. Okay, so forget about it. Let's see our procedure. Okay, so imagine this is our stack. So initially stack is empty because it not containing any type of values at the initial state. At the beginning it is empty, our stack is empty. And imagine now we going to push an element for this stack. So now I put my element. So it is very simple, that element will store at the stack. Okay, so imagine now I am going to push another element, which is B. So now I have implemented our first element, which is A already. So therefore if I inserted B, then it will be stored like this at the top of that following element. Okay, so imagine now I am going to push another element, which is the C or any type of element. So if I put that element, it will be like this. So it will be implemented at the topmost location of the stack. So imagine now I am going to pop element. So popping means basically deleting. So if I pop an element at my stack, it will be like this. So the topmost location is the C position, which means our topmost element is C. So if I perform pop operation, it will be deleted the topmost element, which is this C, just like this. So imagine now I am going to perform again our pop operation. So if I perform our pop operation again, it will be deleted B, because now in previous step I have deleted our topmost element, which is our C. So if I perform that pop operation again, then it will be delete B also. So it is I think this is very clear to you all of you. Basically, imagine a very simple scenario. When you are pushing element, you can only perform that pushing at the top location, and also when you are performing the pop operation, you can only perform that pop operation at the topmost location also. So that is basically how uh, stacks are work. Okay, all basic operations on the stack. Okay, so this is the thing what I said before, because I said when we are discussing about the pop, push and peak operations, I said those are not the only operations that we can perform only stack. There are several things that we can do perform on the stack also. So these are the things. So the push operation we discussed, and the pop operation we discussed. Okay, the third thing is empty. It is a new operation, and the fourth one is full. It is also a new operation, and the fifth one we discuss peak operations. So basically, I explained what are these is empty and is full operation means, because I have discussed the remaining things in the previous slides. So basically, is empty means at its own meaning, it asking that our stack is empty or not. So imagine our stack is empty. Basically, if we perform is empty operation on that empty stack, it will be give an output something like yes, or yes, it is empty, because it is empty. So if our stack is not empty, which means it having some items, so then if we perform is empty operation on that kind of a stack, it will be saying no, our stack is not empty. It is very simple thing. And the fourth one also at its own meaning is full. It is asking for to check whether our stack is full or not. So what is this full mean? Because you guys might be wondering how this is full, how our stack becomes full. Okay, so it is very simple actually, because I said our stack is static data type, which means we should define the maximum size at the initial state. So imagine if we are going to define our maximum size as 10, then our stack only can store 10 elements. So what if I want to implement the another element, which means our 11th element? So it is not practical. So it is impossible to do. So there should be a way to check before implement that kind of a step to stack, because if we are going to store 11th element of that kind of a stack, which having the maximum size of the 10, then it is not practical. So therefore it should be saying no, you can't implement this element on the stack, because this stack is full. Okay, so that is basically is full function means. So if our stack has been reached to the maximum element size, then it will be saying our stack is full. If it is not, which means our stack having some kind of a space, then it will be saying our array is not full, our array having some kind of a spaces. Okay, so those are the main operations that we can perform on these stacks. Okay, pointers and stack operations. Okay, so this is basically how our stack work and the programming state. Okay, so this is very essential So you guys better learn this clearly. Okay, so this is our empty stack at the initial state. So you now should having some kind of idea what are these numbering means. What are the numbering? This is the indexing. Okay, so which means our first element will considered as the zeroth index, and our second element will be considered as the first index, and our third element considered as the second index. Likewise, it will incremented up until to the end. Basically, this is a identification of a place of the stack. So this is known as the indexing. So basically, which what is this graphical representation says is our stack is full at the initial state. Sorry, our stack is empty at the initial state. Okay, so what are these things? Top is equal to -1, max is equal to 5. Okay, so max is equal to 5. You can understand what is this mean, because we having 5 available spaces at this stack, so there will be max is 5, which means we can only store 5 elements at this stack. Okay, so it is clear, I think. And the top is equal to -1. What is this mean? Okay, so this is very essential, very essential. So make sure you completely understood what I am saying right now. It is not a very difficult thing. Okay, so top means I said before, if we are going to perform any kind of a operation on the stack, then it only can perform at the topmost location. Okay, so imagine now I am going to delete operation on this empty stack. So it will first check what are our topmost location. So imagine if you perform the pop operation, which means if you want to delete some kind of element at this stack, is it possible? No, it is not possible because the stack is empty. So how should you indicate that thing? If you want to indicate that thing, you can simply check the top location. So now at the initial state, top is -1, which means now your algorithm knows our stack is empty. So imagine our top is 0. So what is top 0 means? So if the top means 0 is, now the top will considered as this space. Okay, so basically if top means this space, is it empty? No, because top is 0 mean it's containing an element. So imagine top is 1, then it containing another element. It has 2 elements. Top is 2 mean it has another element, which means it has 3 element at this stack. So that is basically how top value increases and decreases. So if at the initial state top is -1, then it simply says it is empty. Okay, so make sure you know this thing very clearly. Okay, so after push an element at our stack, so what will happen? So if I push an element to our stack, the top will be increases, as I said before, because now we have some kind of element, so there will be no top at -1 stage. It will be increases also, so it will be 0, and the max is remain as 5 because max is not can't be changed at this execution period. It is stable value. Max is 5, but top is not stable. It is dynamically changed. That is why I said it has a pointer. We pointing a location. We are to store or we are to delete it. Okay. So now if I push an element to the stack, the top will be increases, which means the top is 0. What if I push another element to the stack? Basically, it will be increases top by 1. Top will be 1, and the maximum value will be remain as 5 because can't be changed. So what if I pop an element, which means I deleting now I deleting an element from the stack. So you guys think what happened to the top and max? So uh, what are you guys thinking? Okay, so you already know max can't be changed, so the max will be remain as 5. So if I deleted or if I pop an element at the from the stack, what happened to the top? Top will be decreases because now we having only one element at our 0th index. So there will be changing our top at to the 0 because it should be pointed top as this element. Okay, so it is very simple. If you are deleting elements, top will be decreases. If you are inserting elements, which means if you are pushing elements, then top will be increases. So like this, top will be 0, next will be 5. So what if you push this remaining element also? If you pop out this element also, then the top will be -1 and the max will be 5 because it should be indicate that our stack is empty. So if you remember, so see this graphical view, so it is empty at the initial point, and at the initial point it says top as -1. So in this position also the top is -1 because the stack is empty. Okay, so if you are curious right now, you should having some kind of a hypothesis. What if again we perform the pop operation? What if we now the stack is already empty? So what will be happen if we perform pop operation again? It can't be performed. That is the simple answer for that, because that is how stack data structure works. You can't exceed it minimum state, which means the empty state, or the maximum state, which means the full state. So you will be seeing what I am saying right now in later. For now, just remember, you can't perform pop operation up until you can't perform pop operation when it reaches to the empty state. If our top is -1, then it clearly says you can't perform pop operation again. So that is how stack operation works. I think you guys are clear what I'm saying. So the top will be remain as -1. Okay, that is everything that you should know about stacks. So we have discussed so many things according to the stack data structure. I think you guys having a proper knowledge about what I taught you guys, and yeah, this is the introduction to this stack, and in the later episode I will show you guys how to use this in practical state, which means how we do our pseudocodes and C codes by using stacks. So thank you. I'll see you guys in the next episode. And simple request. So now I think if you follow this tutorial series up until to now, I suppose this series will be very helpful for you guys if you are involving with any kind of a degree program like programming or software engineering or whatever you are involved with at the computer field. So if you are thinking this channel will be helpful for you guys, first I'm requesting you guys to subscribe this channel, and the second thing is, uh, if you can share this channel with your groups and with your colleagues, so they will be also know this channel, and they will also get something by this channel. So those are my requests, and I kindly asking for you guys to do that thing also if you can, and if you think this channel is valuable. Okay, uh, I will see you guys in the next episode. Stay awesome, stay coding, and stay learning. Thank you.